So today I'm going to cover some topics like percentage change and error calculation. So okay, so because every year we are getting score, so today we are going to see the calculations. Okay, so for example, so let's say if I say y is equal to a square b by c cube. Okay, so here what I am saying is y is a function of a, b, and c. And if I say that while, for example, let us say y is the BP of a person, which depends on the parameters A, B, and C. So what happens, let's say while measuring the BP, we do some error in the parameter A, B, and C. So we want to see finally how much error we are getting in the Y. Okay. So now how to do that? So for that, one condition, there are two conditions you have to consider. One is you have to check whether the error in each parameter is less than 5% or greater than 5%. Okay, so if it is less than 5%, so what you can use is directly there's the formula. So let me generalize this. Let's say if y is equal to a power n into b power m divided by c power, for example, let's say L. Okay, N, M, L can be anything. Now the thing is like, okay, how to calculate the error in Y? So to do that, what you have to do is just write delta Y by Y. Okay, equals to whatever the power is there, you bring it forward, N into error in A plus M into error in B, delta B by B. And if anything is down, you have to still make it plus only if you are calculating error, delta C by C. Okay, so if I say, let's say the error in A is 1%, so you just put delta A by A is equal to 1, and delta B by B, let's say 3%, you put there 3. And if it is delta C by C is 4%, just put 4 there, and just multiply it by the corresponding number N, M, and L, sum it up. That will be the total error in Y. Any doubt? Any doubt here?
No, sir.
No, sir. So please note it down. I will clear. Shall I clear, guys? So can you guys do one question that I will give you? Please note down the question. If the error in measurement of length of a pendulum is 1% and error in the gravity is 2%, then what will be the error in the time period of the pendulum? So what they have given, you know, right? Time period formula. What is it? 2 pi under root L by G. Correct? Everyone know this? Hello. So can I write this as 2 pi is a constant? Forget about that. There is no change in 2 pi. So you just forget about that. So L to the power 1 by 2 divided by G to the power 1 by 2 I can write, right? So how to calculate error in T? It is simple. Delta T by T is equal to, here what is the power of L? 1 by 2. Just bring it forward. Delta L by L plus what is the power of G? 1 by 2. 1 by 2 delta G by G. Okay. Now delta L by L is how much I have given? 1%. Just put 1 here. And delta G by G I said 2. So it is 1 by 2 plus 1. So it is how much? 1.5%. Okay. 1.5% will be error in the time period. Any doubt in this?
No, sir.
Okay. So similar, they will ask, error in anything, like they'll give you error in momentum, they'll ask error in kinetic energy, they will give you error in velocity, they'll ask you what is the error in kinetic energy, and they might ask you like, well, there is a error in some quantity. Okay, so there are many formulas in physics you study, so you should know that formula first, then you use it appropriately, and then calculate. Okay. Now, so here one twist is there. Okay, one twist is there. What is that? They will say, sometimes they will say error, but sometimes what they say is, okay, if the percentage change in length is 1% and percentage change in gravity is 2%, then what is the percentage change in time period? Then you have to do a minus here instead of plus, no? A minus. Why? Because whatever thing is there in the denominator should be with minus sign if they are asking percentage change. If they are asking error, add everything. If they are asking percentage change, numerator plus and denominator minus. Please note these lines. Guys, please note down that whatever I said just now, in error calculation, we add all the errors, but in percentage change, we add numerator errors, we subtract denominator errors. Note down these two lines. Once you are done, please let me know. You guys able to hear me, right?
Yes, sir.
Yeah. You have noted that?
Yes, sir.
Okay, so let me clear. Okay, all right. So now let's see. Okay, this whatever I taught you so far is if the error is, or if the percentage change is less than 5%. If it is greater than 5%, if the percentage change or error is greater than 5%, how to solve? Then similarly, I will take y. Okay, y is equal to a power m b power n by c power l. Okay, anything. So then what you have to do is, first initially you have to do this. Okay, what is the percentage change or error in y, they will ask. Then what you have to do is, you have to do y final minus y initial divided by y initial into 100. This will be your answer, correct? First what you have to do is, first calculate. They will tell, okay, what is the percentage change in a, what is percentage change in b, and what is percentage change in c. So then what you have to do, you consider y final by y initial first. Okay, then what you will get, you will get, right, a final to the power m, b final to the power n divided by c final to the power l. Similarly, you will get a initial, this what you say, b initial, this will be m n, and c initial will go up with l. So from here you will get this value. Okay, how will you get? You have to assume that the initial is 100% and final whatever they will say, okay, this much is the change. So then you calculate it accordingly. Then you will get one factor, that y final by y initial, from this data. Okay, once you get that, what you have to do is, once you get that, since our answer is y final minus y initial divided by y initial, what you can do, you divide y initial both side. So y final by y initial minus 1, right? Since you have already know this factor, you can easily calculate. Okay, for example, let's say if I say that the change in velocity of a particle moving with some speed is 40%. Okay, Now the question is calculate what is the change in kinetic energy. So what I will do is I will say, well, kinetic energy is half mv square, right? So now what I will do, I will say, okay, K final divided by K initial is equal to V final divided by V initial square, right? Rest of the things is constant. So now V final is, they are saying it is 40% change. So initial I will assume 100%, right? 40% change means how much? 140. Correct, no? 0, 0 cancelled out. It became 7 by 5. So we got this factor K final by K initial, 7 by 5. Now, we want what? K final minus K initial divided by K initial into 100. So now K final by K initial minus 1 into 100. Correct? Now, K final by K initial, how much we got? 7 by 5 minus 1 into 100. So it is 2 by 5. 2 by 5 will be how much? 0.4 into 100. So you are getting around 40. Okay, guys. In this case, we are getting 40%. It's not necessary that the change in velocity is also same as change in kinetic energy. You understood the process, right?
Yes, sir.
Shall I take one more example or it's clear?
Sir, can you give another example?
Yeah, definitely I will do that. Just give me a second. So like we know, right, this in modern physics we study one relation P is equal to h by lambda, right? This we know, right? So let's say I will say that the photons wavelength change in wavelength is around 25%. Okay. And now I will ask you what is the change in momentum. Then you have to write, okay, P2 P final by P initial is equal to lambda 2 by lambda 1. I can write, correct? Because inversely proportional. Sorry, it is lambda 1 by lambda 2. Correct? Any doubt here?
No, sir.
So from here, what you do is initial wavelength, you assume it as 100%. Now, how much is the change? 25%. So it will be 125. So from here, you got P2 by P1 is equal to 100 by 125. So you solve it 20 and 5 2s are 10, 5 5s are 10, 5 4s are 5 5s are. So you are getting 4 by 5. But what is our answer? Our answer is P2 minus P1 by P1 into 100. So you anyhow you got P2 by P1. So now what you have to do is P2 by P1 minus 1 into 100. This is your answer. So this is 4 by 5 minus 1 into 100. So it is how much? Minus 1 by 5 into 100. So around minus 25%. The momentum will decrease by 25%. The minus sign means the momentum, final momentum will decrease by 25%. Understood?
Yes, sir.
So you guys know that one more thing I want to tell you. So we studied two cases, right? One is for less than 5% and one is for greater than 5%. The key points, again I am repeating, in error we'll add everything, but in percentage change, we add the numerator part and we subtract the denominator part. Okay. And if error is greater than 5%, then we have to manipulate it. We have to write the formula and then we calculate the final by initial factor. So we do minus 1 into 100 to get our final answer. Okay. These points you note it down because you forget it again and again in the exams. That should not happen. Okay. So now I want to cover some part of, we covered electrostatics, right? We covered electrostatics, no? So electrostatics still where we covered, electric field we covered, right? Now I want
Yes,
to
sir.
cover, yes. So I just want to continue from there. Like I want to cover today a little bit about electric flux, just introduction basics. Okay. So what is electric flux? Anybody know? So for example, let us say I have a charge Q. Okay. Everyone know that from a positive charge, the electric field comes out, right? They spread like this if it is a positive charge. So if I keep a small area here, okay, and a larger area like this. So in which case the field lines are more in area 1 or area 2, guys? In which case there are more electric field lines?
Area 2.
Area 2. So electric flux is defined as the number of field lines per unit area, okay? E by A. Okay, understood? So number of lines per unit area is called electric flux. Now, please take the screenshot or something. I'll go ahead. Now,
Sir.
there is one theorem that is we call Gauss law. Okay, so that is a very important theorem, Gauss law. What it says that if you have a system, let us say a closed surface in which there are charges like Q1, Q2, okay, and let us say outside this system there are charges Q3 and Q4, okay. Then he says that the integral over this surface E dot dA, okay. What does this mean? The integration of electric field over this surface A, this is the surface, closed surface, is nothing but the charge inside divided by epsilon naught. Is nothing but the charge inside divided by epsilon naught. So here everyone teach this, but there is a twist here. There are some points you need to remember. Is that so E dot dA is Q in by epsilon naught. What is Q in here, guys? Q1, Q2, right? So you have to write Q1 plus Q2 by epsilon naught. But when someone asks you what is this electric field, is it due to Q1, Q2 or Q1, Q4 or Q2, Q3, or it is due to Q1, Q2 and Q3, Q4? Who will answer this?
Q1, Q2, right?
To everything, okay? You guys able to hear me?
Yes, sir.
So it is not due to Q1, Q2. That's why I am pointing this out. It is due to Q1, Q2, Q3, Q4. All the charges present in the universe. It is due to that. Okay, it is not just Q1, Q2. It is equal to Q in by epsilon naught. Okay, guys? Any doubt?
No, sir.
Okay. So just let me clear this. You note down that point, okay, where E is due to Q1, Q2, Q3, Q4, and Q in is equal to Q1 plus Q2. Okay. Now, there are some tricky questions they ask in exams many times. So they ask like this. Okay. So if there is a plate of side A, okay, and if I keep a charge Q at a distance A by 2, this is a charge Q, okay. I'm just keeping it A by 2 at this from the center up. So they'll ask you what is the flux passing through this area, passing through this plate. Okay, how to do this is, you imagine a symmetrical closed surface. Which surface you are able to imagine in this case? Like if I take similar length plates, okay, so it will become a cuboid, right? Correct? Now it became closed surface, right? Everyone understanding?
Yes, sir.
So now I imagined a closed symmetrical surface. So from this, if I can say that the flux is same in all direction, right? I can say that, right? The flux is same from the all the surfaces. If there was a cube, the flux will be q by epsilon naught, right? But there are how many surfaces? I assumed total 6 surfaces, but I want electric flux through only one surface, so divide it by 6. So this will be the answer. This is flux through one plate. Okay, everyone understood?
So could
Any
you
doubt?
explain that again?
Yeah, so what I'm saying is, they are asking what is the electric flux passing through a plate from which at a distance a by 2 a charge q is placed. So what I did is I covered it with a closed surface with 6 faces, that is a cube, right? So the total electric flux from Gauss law, what is it? Q inside divided by epsilon naught. So now inside this closed surface, the charge is Q. So the flux throughout this cube is Q by epsilon naught. But I want through only one surface, so it will be Q by 6 epsilon naught, because there are total 6 surfaces. Is it clear now?
Yes, sir.
Okay, so let me twist you little bit, and let me see who will answer that. So let's say I will have a similar plate, but instead of center, this is A, okay? This is A, and A. Now, instead of center, I will keep a charge from this corner at a distance A. Okay, at a distance A above, I am keeping a charge Q. Okay, this is a distance A. Can you guys tell me what will be the flux through this surface? A. Anybody able to solve? Anyone is like, oh my god, I'm not understanding what's going on. Anybody like that? Samhita, are you able to solve it?
Trying, sir.
Okay. So I'll give you 2 more minutes. Let's see if anyone can get it. The hint is you have to close it with a closed surface. It should be symmetrical. Shrita, you got the answer?
No, sir.
Xavian? Xavian?
So can you hear me? Hello.
Of side 2A and then one more plate of side 2A, one more plate of side 2A. So now again it is a cuboid of side 2A, right? And through each face it is q by 4 epsilon naught. Again in one face there are again 4 divisions. So it will be q by 16 epsilon naught. I hope everyone understood this. Everyone understood?
Yes,
Just
sir.
Yeah, just simple imagination of symmetrical figures. Understood, guys? So I'll give you one homework. Okay, so you just try this out. You can now go and solve electric flux questions. Okay, so just let me give you one question. Let's say there is a hemisphere and there is a charge q placed here. Okay, so you need to find me what is the electric flux through this hemisphere. Okay, this is your homework. Okay, guys. So think of how you can make it a closed surface. Now you can calculate it. And also find the electric field. Radius is r. What is the electric field passing through this surface? You have to find that E also. Just you need to multiply the flux by area, right? I hope do you have no doubt in this? Any other doubts you guys have? And how many of you attended the test, full test of physics? How many of you attended the test? Not able to hear anyone. You guys able
So
to
I
hear me?
attended the test.
You got 50 marks, no, Zevian? Good.
I did.
Yes. Niharika, I don't know. She joined today, I guess. So, Shrita, did you
Sir, but I
attend?
didn't attend the test.
Why? Because your exam was over.
Yes, sir.
Okay, no problem. Samhita, what about you?
Sir, I had JEE yesterday, sir. So
How was it?
it was okay, sir. It was only math, it was hard.
Okay, so did my teaching help you?
Yes, sir. But 11th, I struggled a bit, but 12th, I could do if I learned the formulas.
Okay, so like questions from kinematics, work per energy, center of mass, whatever we covered. Did you able to solve those questions?
Mostly, sir. I'm not sure, but like I tried my best.
Okay, no problem. Okay, guys. All right, then I will end the class here. So we'll see you in tomorrow's class. Please do this and practice questions. Any doubt, please ping me in the WhatsApp. I am available anytime to help you guys. Okay,
Okay, sir.
bye.
Thank you, sir.
Thank you.